Hello, welcome back. Today we are continuing to talk about electrons. So in the last class, we talked about how many electrons fit in each orbit of the atom, and that is going to be extremely important on today's topic. So remember from our last class, our electron shells have the 288 rule. On the first shell, you can only fit 2. On the second one, you can fit 8. And on the third one, you can also fit 8. We won't go beyond the third shell. Don't worry about that. So let's begin. So why is it important that a certain amount of electrons go in each ring? So our electrons in the very last ring for that atom are going to be very special because they're the ones that are going to tell us how the atom is going to behave. Is it going to explode? Is it going to be safe to handle? That is what's going to determine what we know about this atom. So as you know, in life, we have many elements, right? Some elements are reactive and some elements are not as reactive. So depending on how many electrons they have on that last ring, that's going to tell us if they're going to react or not. So that last ring of electrons is extremely important, and we call those electrons valence electrons. So again, valence electrons are the ones on the last shell. So for example, in this picture, we have 2 electrons on that first ring, the yellow one. And then we have 1, 2, 3, 4, 5, 6, 7, 8 electrons on the second ring, that green ring. And then on the last ring, on the blue ring, we have 1, 2, 3, 4, 5, 6, 7, 8 as well. So this atom has 8 valence electrons because that's how many are on the last ring that we have here. Now these valence electrons, like I said, will tell us the reactivity of the atom. So think of you and how you react to different things that happen in everyday life, right? If you're walking down the hall and somebody trips and falls down the stairs, how would you react, right? Not everybody reacts the same way. Some people would be very worried and go help the person. Some people would get scared that they'd get, punished for being in the same area or whatever. Some people might just laugh. That's what my sister does whenever somebody falls in front of her. And so every person has a different reaction to everything that happens, and every atom of a different element is going to have a different reactivity as well. And that's going to be dictated by the number of valence electrons. So there's 3 types of main reactivity that we're going to discuss in regards to atoms. We have stable atoms, the ones that don't care what goes on around them. They are themselves and they are happy as they are. We have reactive atoms, which are unstable, and they will react. And then we have highly reactive atoms. Those are the ones that go boom. Those are extremely unstable. They are not happy as they are. They want to get together with somebody else that'll make them happy. And that's how they will become stable at some point. But by themselves, they're extremely reactive. So those stable atoms are when the last shell is full. So in the first shell, like I said, we can only fit 2 electrons. And the element that has 2 electrons is helium. Helium is an extremely happy element. It's able to exist by itself with no issues. It's stable. It's not going to blow up just because it exists. So helium is a stable element. It's happy as it is. It's fine. Its shell is full. It only has 2 electrons, and the first shell only fits 2 electrons. So he's maxed out. He's happy. Then we have, the one with the second shell full. In the second shell, we can fit 8. So if we have something with 10 electrons, then the first 2 go in the first shell, and the other 8 to make 10. 2 and 8 makes 10. So the second shell is also full. It has all 8 that can fit there. And so this atom would also be very happy. It would be very stable. And then the last one that we have here also has 8 on the third shell. That is going to be a full shell. So when either the first, the second, the third, the 30th shell, whatever many shells you have, if the shell is full, it's happy, it is stable. Okay, that means it's not going to be a dangerous element. It's going to be something that will not easily react. They are happy. They don't need anybody else. They are fine the way they are. Okay? There's a very small group of elements that exists in nature that are actually stable, and we'll talk more about those in detail in the lesson sure to come soon. Then we have the unstable elements. That is whenever any of the rings are not full. Okay, so if the last ring that it has is not full, even if the first ring is full, if the second ring, if it has 2 rings and the second ring is not full, it's not happy. Okay, so any atom that has 2, 3, 4, 5, 6 is going to be unstable, right? Except for helium. That's the only one that has the first full shell. If it has 2 on the second shell, that's not a full shell because remember the second one fits 8. So anything that has 2, 3, 4, 5, or 6 on their second or third shells, it's going to be a reactive element. It is going to react. They need somebody else to make them happy, to fill up that shell with more electrons. Okay? They by themselves cannot be happy. They cannot be stable. They need to join with somebody else to make that shell full. Okay? So think of the ones that will beg, steal, borrow, share with somebody else in order to be okay. Then we have the extremely unstable. So those are when they are either furthest away or closest to a full shell. So if they only have 1 valence electron, they need to get another 7 electrons in order to be happy. That's a lot of electrons. It's harder to find somebody that will match with you then, right? So those are going to be the extremely reactive ones, the ones that will have the most reaction whenever we have any issues, right? They want to be stable. Remember, all atoms want to be at that happy place. They want to have their shells full. And so if they're the farthest away, like 1 valence electron, or they're the closest, they're like, oh my gosh, I just need 1 more electron. Where can I get it? I am so annoyed that I only need 1 electron and I don't have it. That's our 7 valence electrons, right? So when you have 1 or 7, they are extremely reactive. So it's either really far away or it's really, really close and they can taste that 8th electron, but it's not there. And so they're also very highly reactive. Highly reactive also means extremely dangerous. So we're going to talk about just how reactive an atom can be. Okay, there's a demonstration here. I would do it live, but I do not want to blow up my apartment. And when I tried the last time, things didn't go well. So here's a video. I will link this video in the card if you want to watch it in more detail, because I don't want to get copyright stricken. But we will also be watching quite a few of these in class to see more examples of reactivity. And I might be able to do one demonstration if I'm able to go get the chemicals from the classroom. All right. If not, whenever we go back on October 19, I'm making that demonstration in class. Now, the elements you are about to see have 1 valence electron, if you are going to watch this video. And so they are the extremely reactive ones. These are going to explode when you drop them in water. That's how reactive they are. So I'm just going to very briefly play a little part of the clip That's the smallest. So that's just dropping a drop of water. So that's an even more reactive one. All of these, it's a very tiny amount of that element in just a drop of water. So that's one example. You can watch the rest of them and we will watch it in class as well. So that is it for today. We will watch all the demonstrations in class. I have a video with a few cooler ones, and I'm going to try my best to get some of those chemicals in my possession and do a live demonstration. I hope not to burn down my apartment, but like I said, we will do it in person when we go back, okay? So that is it for this video. Let me know if you have any questions in class, and I will see you then. Bye.